Reality, captured in user-friendly symbols and processed for understanding. The Idea Channel.
Charlie, there has been continued public interest in the question of life outside of our own Earth. That's witnessed in the endless science fiction movies that the children all see, the comic books of aliens in space, and the scientific search for extraterrestrial intelligence. What do you think's happening? Should we be doing this? Is this a sensible strategy? Are we going to find something? These are things we can talk about, but...
Well, I think it's clear that it's a fascinating subject, terribly important if there is life out there that we can contact. Tremendously important and fascinating for that reason. But it's, of course, a big gamble. Is there anything there, really? And how can we find it if it's there, and so on. So it's one of these magnificent goals which may or may not ever be attained. And how do you decide how much to put into it?
How much energy and money?
Yeah, but it's a fascinating speculation, and I'm not against trying and looking. I'm not doing it myself, but I think that it makes sense to look some.
Well, I guess we have all opinions on that. Some people are afraid to know. Other people desperately want to know. Other people are convinced that there can't possibly be other life on Earth other than on the Earth. Some people wonder if there is intelligent life anywhere in the universe. So there's all options out there. Bernard, how are we ever going to even know? If SETI's out there looking, how will we even know if they've discovered intelligent life?
I think there are two different questions. One is the existence of life and somewhere else, and secondly, whether we can see it and discover it. That are two different questions. Now, on the first aspect, I am amazed just by the orders of magnitudes. Every square degree in the sky that we can look at, we see 500,000 galaxies.
500,000 galaxies.
Each of them are maybe 100 billion stars. Yeah. Okay, and each star may have a few planets in average. So there are a very large number of planets and very large number of possibilities for having life somewhere else. Now, of course, we don't know what is the probability for this life to arise.
On any one star.
On any one star, what is the probability? That's not a very scientific question for the time being.
There are some things we do know that people for a long time used to wonder, well, is the other side of the universe even like our side? Does it have the same physics? Does it even have elements that we know about? But those answers we can answer in the affirmative now. We can see oxygen, hydrogen, all the common elements, nitrogen, iron. We can see those in galaxies on the other side of the universe, and we think the physics, I mean, we're convinced the physics is the same everywhere.
Yes,
the universe is the same
I
physics.
think that's something on which all scientists can agree pretty well now.
That's right.
So we are not a very special place in the universe. There is a full Copernican idea that we are just one random place in the universe.
Certainly not in any special place. On the other hand, one can wonder whether the presence of life on Earth is something very special and unusual. For example, the Sun has quite a number of planets and moons around it. We haven't yet seen any planet around any other star. Now that's of course because we're not good enough yet. Someday probably we will. I would think the probability of other stars having planets is high, but we don't know for sure.
But you begin to see dust, a lot of
dust. You see dust. I think there's every probability that there's something there, but we don't know that for sure yet. Now the thing that is much more speculative is what are the chances of life forming? Because, see, there are a few things we know. We know on Earth that life has formed, so surely it can happen. But we also know that we're all related. Life formed only once here. The Earth we think of as a very favorable place after all. Nice temperature, water, lots of garbage around to feed on, and it's a very favorable place. Why shouldn't life start many times here? And it started only within a billion years of when the Earth was formed, but it started only once. We know that because we all have the same helicity in our molecules. Our molecules are all left-handed, we say. They're not right-handed. Right. And right hand is just as good as the left hand, and why shouldn't they be if it started more than once? So it was a unique event. Now, another thing is that it had to happen apparently at just a particular time. The Earth was accumulating carbon dioxide. It was coming out of the core of the Earth, carbon dioxide, filling up the atmosphere. Life got started just at the right time to feed on that carbon dioxide, but before it got too hot. Venus has so much carbon dioxide, it's too hot, everything melted, it even melts lead, and nothing could live there.
Right.
So life formed just at the right time when there's carbon dioxide, plants could form, they could then produce oxygen and produce other life. So there are a lot of happy accidents here.
Is it true that the oxygen that you have around the Earth was basically coming from the living?
Yeah, the oxygen wouldn't be here except for plants.
The oxygen wouldn't be here, but in fact, removal of the carbon dioxide did not depend on life entirely. Although nowadays it's limestone and dolomite, and that's mostly life forms that are pulling carbon dioxide out. But I'm told by my geologist friends that, in some of the articles I've read, that you can have carbon dioxide precipitation in the ocean even without life. So there's a lot of it buried.
Yeah, but I think the geological history of the Earth is the carbon dioxide was building up.
Oh, yes.
It was building up, life appeared, plant life, and it began to fade.
Okay.
So that was a critical time, and we might have gone the way of Venus. If you look at all the other planets around the Sun, we're convinced there's no life there now. There might possibly have been some life on Mars at one time, but the other planets are not favorable, only the Earth. So a lot of happy accidents. Now, on the other hand, as improbable as all those accidents are, nevertheless, with the number of stars you mentioned, billions and billions and billions of stars, and clearly there's still a chance, but we can't say how much of a chance. We can't calculate it, unfortunately.
Well, people try to calculate it, but I don't know that we should give those calculations much credence.
Or there are 10 different factors of the probability of having planets with the right environment, the probability of having life starting on the planet, probability of this life to go on long enough for intelligent species to really to develop. And so on, and all of these factors we don't know.
That's another thing. We have on Earth one species that we think is intelligent, and at least has been able to produce technology and can make some signals, but only one. Only one is developed even on Earth. All the richness of fauna and flora here, there's only one of those. That's another peculiarity you see. And how probable is that?
It took 5 billion years.
Took 5 billion years, and there's only one of them.
Now, suppose the comet had never, I guess the comet hadn't struck the Earth 65 million years ago to kill off the dinosaurs.
That's right. Then
we may never have developed. The mammals may never have gained ascendancy.
That's right.
And the most intelligent life form might be some developed bird.
Right.
Some sort of
and would they have developed technology? We don't know, of course, what would have developed. But I think one has to say the probability is very small. But on the other hand, you'd think that it can't be. It's hard for to imagine it be so small that there's not some life somewhere else.
Well, it's also so hard to understand the development of intelligence in this term. The dinosaurs are perfectly content, extremely successful species, been around 150 million years.
Biologically very successful.
Extremely successful. They seem to do just fine. And intelligence has only developed in humankind in the last 10, 20 million years, I guess, or probably less. Not a fleeting moment of time. So maybe intelligence isn't really necessary.
Of course, this is the thing that many people argue that, well, since there surely has to be some other intelligent life somewhere, this other intelligent life might be 1 million years ahead of us. That's a very short time. They would be so much more skillful than we, so much more knowledgeable. Maybe they're watching us all the time, know exactly what we're doing. They don't bother to come by. They don't want to disturb us. And so on, but they have technology far beyond ours, and of course, if we could contact them, learn that technology, just think what that would do.
Yeah,
It'd probably make us ashamed of ourselves, but...
They could be the reverse. They could also have existed a few million years ago and destroy themselves
Yeah,
and not be there
that's
anymore.
quite right.
So
well, that was one postulate.
That's
We've had many postulates here. One common one was, well, of course, we've got life on Earth. It must exist everywhere. We can't be special. It must be life on every planet. Well, we soon found out that wasn't quite right. Then another postulate was this one you mentioned, that, well, life gets up to learns how to build a nuclear bomb, and then they kill themselves off, and so that's the end.
So
given the difficulties of interstellar travel, has been noted for many years, that although we study the stars and galaxies, and wistfully wish we could get close to these black holes and other exotic objects to view them close up, we know that's impossible, that we're never going to make the trip. I mean, the laws of physics are such to make interstellar travel rather difficult.
Difficult. I would not discount that completely, though. You probably know Enrico Fermi's answer to whether there was life on other stars. His was that, well, where are they? They should be much more advanced than us. They should be traveling all around. They should have stopped in to see us if they're there. Why haven't they come? They must not be there. Now, I think interstellar travel, it's clear. You're quite right. It's very difficult, but there are possibilities physically. First place, for us at least, we would have to travel in a company and have several generations, many generations before we got there.
yeah, it's just a time necessarily.
Yeah, that's right, a long time. That's many generations. But of course, we also don't know how long other people can live. There may be technologies that will allow much longer lives.
People to go into cryogenic state for a few million years.
That's quite possible. Or simply increase their lives by several orders of magnitude. We don't know what it is that makes people age.
Yeah, that's it. So really, one of the basic questions behind this whole subject. We have no idea what life, other forms of life could be, and we have no idea of the capabilities. We have no idea of if we define life just as a self-sustaining system which has some kind of intelligence, we have no idea what the other forms could be.
That, of course, makes it all the more fascinating if we ever find somebody.
Yes. Now, that's the second aspect of the question. Can we find somebody? Do we have the technological means to find anybody? If another civilization like ours existed close by, can we see it?
That, of course, we know how to calculate. We know what we can do. Right. We know what we can project what we might do over the next 50 years or so. We can calculate that, and the numbers say yes, we can communicate with stars that are fairly distant. Probably it's practical to communicate across our galaxy, certainly with a few thousand light years. That we can do right now. With a directed beam, we can do that right now.
That's right.
But if we are not using a directed beam, for instance, we are putting a lot of radio waves in the interstellar medium, but because of our own communication, but we are not directing these beams at the other stars. So how far can we be heard?
Well, of course, if it's just omnidirectional, that's difficult. But people have suggested that maybe somebody is listening in and overhearing our normal communications, even though we're not beaming up there. I think that's rather unlikely. The distance is short. But if you purposely do it and try to communicate, then you can go an enormous distance. Now,
but then there are 100 billion stars in our own galaxy, even if we are beaming.
Well, first place, you can make a beam that covers quite a few stars. It's big enough to cover quite a few stars. Next, you can hop it around. The best thing to do to get high signal is to hop it around, so the signal noise instantaneously is pretty high. You can jump it around, so you can cover a lot of territory. Another question is, well, how much money and effort are we willing to put into it? You know, if we were willing to put $1 trillion into it, then we could have 1 million antennas.
That's right. All of them looking at a different frequency.
Yeah, different frequency, different star. But then, of course, you'd say, well, where should we look and at what frequency?
Right. And it shouldn't be in the radio at all.
Well, that's an interesting proposition, because when this was first written down by Cocconi and Morrison, they first suggested, yes, we should be looking, we can communicate. They pointed out the radio waves. This was the way to do it, clearly. Well, we knew radio waves.
It was the 50s or the 40s.
That's right. Well, it was the late 50s, I believe.
Late 50s, yes.
Now, radio waves we knew how to handle. We were good at radio techniques, and so that was the thing to do. But pretty soon along came lasers, and now we realize, well, at least some people think, I do, that one could somewhat more advantageously communicate with lasers, particularly in the infrared. The mid-infrared looks a little more advantageous. But it's a question, well, what frequency? And each frequency has to be very, very narrow. You're on a radio channel, it's very, very narrow. And is it this one or this one, the next one to it, and so on? How many different channels? At the moment, of course, we're looking over millions of channels, but that's not enough.
Yes. Now, there has been getting back to the question of life, there's been the question of whether life would be carbon-based, how similar it would be to our life if it were formed. I mean, most scientists, I think, would say carbon is the most natural element.
Silicon being another possibility, but very difficult.
And much more difficult to form the long chains of chemicals that
well,
are needed.
I think life requires such complex chemistry. I doubt very seriously that any other kind of chemistry would work. It's amazing that this one works.
There is some suggestion, maybe it's whimsical, but I think Hoyle and Narlick are serious when they say that there are possibilities that life rained down from dust in the interstellar medium, that there is some hints of, perhaps maybe we shouldn't take this too seriously, but there's some hints of organic molecules in the interstellar medium. There certainly are some basic organic molecules.
It's clear they're really quite complex organic molecules.
Yeah, in your own work you see lots of molecules which are very complex.
Is it conceivable that life was seeded throughout the whole galaxy in a similar fashion through these organic molecules in the interstellar medium?
It's conceivable, I believe. It would have been seeded in a very, very primitive form. Of course, a virus or something like that. That's conceivable. But even there, where could it live and develop?
But
only in our own solar system, only on Earth. The rest of it.
You have to have the right conditions for these things to
just the right conditions. I think it's rather unlikely, because while there are many complex molecules in space, many organic molecules, we know that, nevertheless, things floating through space, particularly near a star, are subject to ultraviolet radiation and light radiation, are likely to have imperfections in them, just the way we get cancer from exposure to light. Those things are likely to be destroyed or disrupted, not completely destroyed, disrupted enough that I think that's very unlikely.
This is a very serious problem, even if men wanted to travel to Mars. It's such a risk, being exposed in the unshielded environment for a year. They're likely not to survive.
Oh yeah, they'd have to have a very special environment constructed for them.
People don't appreciate the role of the atmosphere in shielding
we
us.
just, it's just remarkable what the Earth is like. It's just precisely built for us, it appears. We're built for it. Who knows?
That's all different questions. Is why there are so many miracles, in some sense, in the universe, which has allowed us to exist, even to form elements above carbon. They have been to be very special.
Very, very,
set
we need iron.
Of nuclear cross-section.
We need iron.
Remember what Hoyle was saying, that he postulated that in order to build carbon out of 3 helium atoms.
Required a minor miracle of nuclear physics. That's right.
Miracle of nuclear physics, which happens to be there.
Yes.
And then we need all the very special conditions in the stars and the supernovae and the neutrinos in the supernovae to be able to.
That's what people have been calling the anthropic principle, of course. The anthropic principle being that the laws of nature, if you want to look for new laws of nature, look for laws which are consistent with our being made and being here. Well, of course, we are here, so we know those laws are consistent. But which came first?
That's it. this
which
is
came first.
one of the. Okay, your statement.
It's just it's just automatic. If we're here, sure, the laws of nature are such that we're here. But maybe there are many other universes that exist in which we couldn't exist.
Especially in this recent few years, there have been these fanciful theories of everything suggested, which suggest that there could be many different types of universe. Not that they could ever communicate with each other, but that these universes could have very different physics.
And then a strong statement of the anthropic principle would be to say that only the universes which can develop life, our universe is just like it is because it's the only universe which could develop life and have an observer like ourselves.
Most people would say that's going too far.
Yes, I would agree, but look, it's an attempt to try to reconcile the randomness of all this natural phenomena and the kind of miracles that we were speaking about and
special situations
in
which we find ourselves.
Yes. So if you don't want to invoke a master plan or invoke some special properties of nature to self-organize, and you want to reconcile randomness with what we see today, people are just invoking the anthropic principle as one possible answer.
So I think for many people this has a strong religious meaning, and one can speculate about what would it mean to people who are religiously oriented, as well as what would it mean to people who are simply scientifically oriented, not religiously oriented, if some other form of life does come into our view. And maybe a form which is much superior to ours in terms of intelligence and abilities and so on. What would that do to people's thinking?
What would be your reaction? We know that you are somewhat religiously oriented.
Yes, I consider myself religiously oriented as well as scientifically oriented. I would be fascinated, delighted, and fascinated.
But what happens to the Bible?
This is more of wonderful creation.
Yes, what happened to the Bible?
The Bible is still there. The Bible is still there, simply not complete. It doesn't describe everything. It doesn't tell us the details of everything. I think
agree with you that actually that will be for religious people, that would be if properly interpreted just another example of the richness of the world and of the creation and so on. So
right. For others it would be difficult, I think.
It would be difficult. There are others who will not even accept the idea of evolution of life on Earth, in spite of the evidence, the amazing preponderance of evidence for it. I mean, it's very similar to the people who believed in a flat Earth. I think the Flat Earth Society has pretty much receded these days, but sometimes...
Pretty much, not entirely.
Not entirely.
I get nut letters on that every once in a while still.
I mean, it's inevitable. I mean, any thinking scientist must realize that there must be intelligent life that far exceeds our capacity out there, given these numbers that Bernard was saying. It's got to be intelligent. Whether or not they have any desire to
I wouldn't say there has to be. I would say likely there is. Okay. But who knows? We absolutely cannot calculate what the probability is, you see. And I think the biggest sticking point is what is the probability of molecules getting together to form a combination that builds up into life. We can think of mechanisms of maybe how it might be done, but we can't calculate a probability. We're just completely hopeless. We can do something with saying, well, how many planets might there be? How probable is a planet? How probable is a given temperature? How probable is it that there'll be water? We can make some reasonable estimates maybe. But we have absolutely no number for saying, well, what's the probability of molecules getting together in this particular way and doing this? My guess is it takes some very, very special circumstance. And this is why it happened on Earth only once. It took a particular environment on Earth, a particular local environment, probably a particular gross environment that it happened once. But how and why?
Charlie, I'm not sure I agree with that last statement. And from what I've read, I had the notion that a lot of biologists who really think about these matters, more so than I, have the opinion that the formation of life to a certain degree is almost inevitable if the conditions are right. Now, what conditions are right means is a little unclear. What I think is the most difficult question is another question we raise, is what is the chances of this life ever becoming intelligent? I agree entirely that we have no way of estimating that, but I'm not so sure that the formation of primitive life is a remarkably unusual circumstance.
Well, I guess I disagree with you there some. The biologists have put together mechanisms that they think, well, maybe this molecule and this added together in certain ways, but they have no way of calculating that probability. And I have not seen anybody that's attempted to calculate that probability. They may have a feeling that, well, okay, it's going to happen just the way we say, well, there's life here, so there must be life in other places. But I believe there's absolutely no numbers.
I think I would agree with that, but in some sense, in terms of the probability of any one situation working, it's not the same thing, because you had hundreds of millions of years of warm water lapping up in soap films or bubbles on the surface. Maybe you had clays exposed in one region and many different environments on the primitive Earth, only one of which needed to form life. But but you can't cover. You got all types of options. You have, the probability of any one of them getting anywhere is minuscule, but you have so many different experiments
happening. But maybe it's 10 times more minuscule than you think.
Well, of course.
Maybe 1,000 times more minuscule.
And
after all, it happened only once.
Well, in terms of happening only once, I'm not sure I agree with that either. We know that one side won.
Yes.
We don't know that there wasn't both right-handed and left-handed molecules.
And the right hand was eaten up or something like that.
Yeah.
On the other hand, life exists on Earth in many forms. They all feed on each other. And life still exists. There are always niches and places where a bit of life escapes and manages to keep going. So I think the probability of killing out all of the right-hand form is very small.
No, it has to occur very early on, otherwise.
Yeah, it'd be very small. Otherwise, always niches here. And as I say, we feed on each other.
But we are certainly...
And yet, all kinds of life forms exist still.
There's certainly been mutation trying to get right-handed bacteria or whatever, and then they have been destroyed. But the one thing which is interesting for me is whether science says or recognizes that there is a tendency for the universe to organize itself, for life to occur or not. Is this just a random process, or is this a self-organization trend? And
well, a lot of people have mistaken notions about what the second law of thermodynamics means, and they misuse it constantly in this question, because the usual question is if you take a bunch of material in a heap, the chances of it ever forming into a finished watch is negligible. The chances are overwhelming according to the second law of thermodynamics that things get more disordered with time. It'll turn into more of a heap. The dust will spread around over time and it will not organize. But the universe and self-gravitating systems and systems that are out of equilibrium don't behave with the second law of thermodynamics being obeyed at every point in space.
It's because we have a system which is out of equilibrium.
It's out of equilibrium. It's obeyed globally, but locally organization occurs as ice crystals form. As ice cools down, for example, you get organized water. The water comes out of a random state and finds itself later into an organized crystal lattice. So the second law has to be applied very, very carefully.
There is also so-called chaotic phenomenon, where you can have an instability. If there's lots of energy flowing, you can have an instability that builds up to high peaks of something that's very improbable otherwise. It seems very improbable on a random statistical basis, but it can happen.
That's all the work of Prigogine and all the...
That's right. All of this is...
Well, people are looking, of course, for signals. And they're looking mostly in the radio region. And some have recently reported they saw some suspicious signals.
That's right.
What do
you
you
were,
make- what
you
do
were
you make
saying
of-
that your former student, Al Betts, has also looked for signals once, and he saw something.
Yes, he's looking in the infrared, which I approve of. I think that's a reasonable place to look, as well as the radio. And he's using the some telescopes we have built, and he did see a signal.
Right,
Now he's been at it much shorter time than the radio people have.
right.
But like the radio people, he saw something that might be a signal, and then it went away. It doesn't repeat itself. And you and I know, as experimentalists, you see some little flick of something,
Yes.
and it may come from who knows where.
But what was the characteristics which
Well,
meant
It
that
was
probably?
what they see is a narrowband signal, a narrowband signal that is much above noise coming from a particular direction. Now sometimes people put in criteria that, well, it has to be frequency modulated, because frequency modulation is very improbable, they think, in natural phenomenon.
So it's
Amplitude modulation is more probable.
So it's a line, okay, one particular frequency which changes.
yeah, they're looking for a carrier wave
Yeah.
on a background.
No.
You know, Major Armstrong, who invented frequency modulation, he fought for his patent on the basis it never happens in nature. So hence it was an invention.
So that's
Now-
that's basically our FM.
Yeah, FM radio. He invented
yeah.
FM. Now it does happen in nature some, but not as
Not
likely.
the same way. Now the argument, there's a recent report by Horowitz and Sagan, I believe, in the Astrophysical Journal, where they're reporting this ongoing search happening at Harvard Observatory in the east. At least I think that's where they're running it, or is this SETI itself?
No, that's a separate telescope.
Yeah, okay. Well, they're really specifically looking for what they call chirp signals, where the signal is, the frequency of this peak is moving in accordance, and it has to move in just the right way after you take out the Doppler shift of the Earth's rotation in orbit to keep it at a steady frequency. So that is to say, it's a constant frequency in the emitted frame. And they see these little spikes, but they never repeat, and they've seen a bunch of them, and they're not claiming it's life. They say it might be an astrophysical phenomena. They don't know what it is.
Well, I think they're acting very properly scientifically. They say, well, we have some signals, they don't repeat, and there might be a variety of things. Of course, they're looking for life. It'd be very exciting if that were it, but the probability, I think is quite small. I personally think that I'm pleased they're looking. I would not want to do it myself. I think the probability is so small.
How many efforts are we speaking of? How many people are looking?
Well,
How many groups?
I would say there may be half a dozen groups that are looking in different ways, and they're spending some few millions of dollars per year.
And do you think that is appropriate?
I don't think that's unreasonable. I wouldn't argue that we have to do it, but I don't think that's unreasonable.
But you don't think that we should spend trillions of dollars,
No.
as you were suggesting?
not
that-
true.
No, we shouldn't.
It's probably not even billions.
You know, it's like if you're buying stock, you should buy only a small amount of these very uncertain ones.
Yes.
But maybe buy a little bit of it, just to take the chance. I believe in searching around. There's a lot of things we don't understand. And I believe we should look and think and hope and try some of these things. They may not work. We have to recognize that.
High risk, high
But if
payoff.
they do,
Yeah, if they do, it's
exciting.
absolutely fantastic,
Yeah.
of course. And we'll have to live with a
Yeah.
totally new vision of the world. Yes.
So, I mean, this is getting beyond the idea, though, of searching for episodes of I Love Lucy that this civilization was broadcasting. I mean, presumably, we're talking in most cases that the sensitivity of these experiments requires them to have sent us a directed beam.
that's correct.
And there you have to
That's
ask the
correct.
question. We're
That's very
working,
special.
right now our experiments are what we call passive mode.
Yeah.
We're listening, but we're not
We're
sending.
not bothering to try to broadcast to them. Why should they bother to try to
Yeah, right.
broadcast to us?
What is in it for them to broadcast to us?
Yeah. Well, maybe we have to leave it at that point, because it's about
Very
as
fascinating
much as we know.